Thank you. Good afternoon, everyone. I have never had with live music on the bill, so I have to entertain you all. Like, I don't have a choice here. So thanks for the introduction. As Austin said, I'm CTO for Data Privacy and Security within our security division. And today we're going to talk about security and privacy for big data. And since I'm from Southern California, Redondo Beach to be precise, I thought I would start with a surfing analogy. That's not one of my paintings. I'm not that good. That's a photograph. And does anyone recognize that? Anyone know what that is? So that was a guy who surfed the largest wave ever known to be surfed. 90 feet. I mean, can you imagine? Like, when the waves are above 7 feet, I'm kind of not going to go in there. I don't surf, I boogie board, but still, you know, I know my limits. The reason I have that is the surfing analogy is this, it's just like agreeing on the definition of what big data is. It's just like getting a group of surfers to agree on what is the perfect wave, because everybody's got a different definition. And they're all highly dependent on your perception, your skills, your experience, and then your goals. And until early 2003, no one thought that that was possible. But you know how they did it? They started using jet skis to tow the surfers out. And that's what they do, whether it's Chapu out in the South Pacific, or this is Algarve off the coast of Portugal. These guys have these high-powered jet skis, and they tow out, and then off they go. And it's really the same thing around big data, that you know, it's like this perfect computing mega wave, because you've got this ability to bring together all kinds of information and do things that were never thought possible before. But it's also potentially very dangerous, and you know, it can be a bit scary. There are some challenges with big data. First of all, the name is completely inaccurate. It doesn't have to be big data. And also, there's a lot of vendor hype. And you know, at some points, it gets absolutely ridiculous. So I'm going to talk about separating the hype from the reality. What are people really doing with big data? And then what are some of the security and privacy concerns and controls? So I'm going to kind of skip ahead a little bit. Let's do like a kind of a show of hands around the room. How many of you have worked with Hadoop before? Oh, yay, okay. How many of you have no idea what Hadoop is? Just a couple. So we can skip the basic stuff. I'm totally fine with that. Oh, we've got a whole bunch of late folks. Come on in. I'm so glad to see you instead of watching live music. That's awesome. I will do the short history lesson, because when I wrote the book, I wrote the intro chapter. And it was really interesting to uncover where big data came from. The term was first used back in 1997. It was an IEEE paper on virtualization, and they defined the problem of big data. So back in 97. Then a guy named Doug Laney at Gartner in 2001, he coined the term about velocity, variety, volume of big data. Then we flash forward to 2004, and MapReduce is invented, which is this paradigm, this programming method of taking, you know, huge, inexpensive clusters of Linux boxes and splitting up the workload and being able to drive that I/O as fast as you possibly can. That's really what big data is all about. It's, you know, driving that volume, going fast, and then doing some more sophisticated processing. So that was in 2004 when and that was a couple guys from Google. Then 2005, we have Hadoop and HDFS, which of course is Doug Cutting, and most of you may know that Hadoop is named for his son's pet elephant, stuffed elephant that is, not a real one. So I am going to talk about the 5 V's of what we really consider big data, because everybody has a different definition of what it is. And IBM, what we define it as extracting insight from an immense volume, variety, and velocity of data in context beyond what was previously possible. Big data comes from many different sources. We've got your traditional and transaction application data. A lot of clients are just stuffing Hadoop environments with old transactional data, thinking they'll do something with it at some point. There's kind of that throw it on, you know, in there and then see what we do with it. Machine data, you know, in the last 2 years since I first wrote this, and I've been updating it, machine data and Internet of Things, you know, that is going to drive way beyond volume we even know about today. Social data, same thing, but there's a lot more variety of it. Like, how do you mine a tweet? How do you do text type searching to look for proximity of words? And that's a lot of the work we've been doing with Watson. It's around text analytics. And then we have enterprise content, and that could be virtually anything from images, etc. So there's really a wide variety of what we consider big data to be, this plethora of ideas around information and getting insight out of it. There's one big V that's missing in a lot of these discussions, and that's the value, the business value. And earlier this year, Gartner did a little survey to say, you know, what are the inhibitors for you with big data? And it's getting value out of it. A lot of executives, business executives, are going, well, this is cool, but you know, show me something that gives me value. And that's really what I think a lot of organizations are not quite mature yet. And it's also why I think a lot of organizations aren't doing a lot in the area of security quite yet, because they're still trying to figure out what to do with it. So of those of you who've worked with Hadoop, how many have Hadoop in production? Production. Now, yeah, production now. Not really. I saw like 1.5 hands. That's exactly what I'm seeing as well when I talk to my clients around North America. They're still trying to figure it out. And also a lot of the Hadoop projects, there's skunkwork projects over in marketing and in security. We have no idea they're going on. So there is also this really big disconnect that to me is very disconcerting. Real briefly, I'll talk about the value and some of the things that we're seeing, trends. A lot of it is about processing real-time data and streaming data and applying algorithms, whether that's fraud detection when someone's trying to use your credit card. It could be getting that 360-degree view of a customer and their habits across what a lot of retailers call multi-channel. Like if I start on my iPhone and then later I want to browse on my iPad or my computer, I can do that. Some very interesting work around predicting weather patterns, whether it's for planning locations of turbines or oil rigs, or using that to do predictive work around disaster planning, etc. So there's some really amazing success stories. Most important to me is the one in healthcare. Life-threatening conditions, I can monitor all the devices in a neonatal unit, and I can predict when things may change, when the situation may change, and be proactive about changing medication or changing the care plan for an infant who's at risk. Now we get down a little bit and we talk about the technology itself. There are a lot of capabilities in Hadoop besides just what we call MapReduce. So there's a lot of this federated discovery and navigation. What's interesting? Big data is different because a lot of times you're trying to figure out what's interesting first and then decide what you're going to do about it. It's also, as I said, about storing massive volumes of data. The newest trend that I've seen is Apache Spark. Anyone know what Apache Spark? So this is taking Hadoop and putting it in memory. It's 100 times faster. 100 times faster, and you can put it in the cloud. That's changing our world at IBM. We're really doing a lot of work around Spark because it is a little bit challenging when you're deploying a Hadoop infrastructure because you got a lot of hardware. So what I see going on is I think a lot of clients are jumping and they're going they're not even experimenting, they're going right into the cloud. And they're looking for purpose-built apps like now we have a Watson in the cloud. You can give it a spreadsheet and it'll start telling you information about that and answering questions you didn't even think about. So more will be going into the cloud, more risk. The stream computing I mentioned, text analytics is becoming even more important as we're ingesting more information. And then I also do see this challenge around integrating data and especially making sure that it's a high quality. Very briefly, Hadoop is really an alphabet soup of components. And this changes all the time. What was MapReduce is now called Yarn. Every week there's new components added. The important ones are probably Hive. That's the data warehouse for infrastructure. You've got HBase is a column store, and you can do queries against it. You even now have Big SQL, and you can use JDBC drivers to do SQL queries. So, as app developers, this starts getting very interesting because how do you scan apps to figure out what it's doing, right? You know, a lot of times it's just a REST API and you don't necessarily know what's behind the scenes. Here's a sample big data architecture. And I say sample because everybody's doing it a little differently. You know, one example could be data in motion. I'm taking information feeds off the car assembly line for one auto manufacturer. I'm applying real-time analytics to determine, are there any issues with quality? So any kind of predictive quality and maintenance that we can do to identify potential problems on the assembly line. So that's your real-time analytics. You also have some degree of data integration and cleansing and standardizing data. And there's two schools of thought on that. You know, one is just get it in there and start doing some analytics quickly. The other is make it nice and pretty and clean. I think there's use cases for both. We call these areas landing zones or analytic zones. And when we get to the security and privacy approach, a lot of what we do is around zoning and fit for purpose security and privacy. And a lot of cases, my clients are also taking not just Hadoop, but they're putting either NoSQL databases or traditional data warehouses alongside, whether that's a Teza, Oracle, Teradata, what have you, and then you've got like MongoDB, as an example. So we see a lot of this mixing of different kinds of databases and data sources that people do consider, quote unquote, big data. And the slides, by the way, are on PDF, and I've given them over to Austin, so you'll have that material. Now, front end, what does it look like? A lot of analytics, a lot of purpose-built tools, exploration type tools, like we've got one, and there's tons of those, and this idea of navigation and discovery. What I think is going to be most interesting and important for all of you is operationalizing it, and when this gets into decision management, where I've got a web portal and I need to be doing real-time decisioning and feed in some analytic result that's computed, a customer's propensity to upsell. Like maybe I want to cross-sell them a car rental along with their trip to Hawaii, as an example. Or I may want to look at their risk and then either reject them for whatever reason or flag it as a potential fraud situation. All right, now we have this concept of the data lake versus a data reservoir. A data lake is the data, like the water, flows in naturally and it just sits there. That's good and bad. And then we have the data reservoir, which is built to extract the value from the data. As I said, there's pros and cons. The data lake can be really challenging because think about the security and privacy exposures in there. If you're stuffing all of your data in there, you're not looking at it, you're not vetting it, and also if you're ingesting third-party sources, let's say you buy third-party data, you're not vetting it, you're exposing yourself to a huge amount of risk. I advocate that data lakes are okay if they're restricted use and they're used very tightly, that's okay. But really, data without analytics is just a liability. So you got to think of what you're going to be doing with that information, regardless of what marketing tells you that they need the data. There's a huge risk, and typically your compliance and your privacy office and risk and security will start taking a closer look when it gets to production time. So let's move ahead and talk about security and privacy considerations. Now this is fun, and I think as security and privacy professionals, our biggest challenge is getting to these shadow IT organizations and not being the no department, the NO department, but you want to be the KNOW, the one who's in the know, who can help harmonize security and privacy with what they're trying to do. Because you don't want to hinder innovation, but you want to make sure that you protect it adequately. So, whoops, let's go back. So why is big data different? First of all, I said more data and more risk. The more data you have, the higher risk of the breach. Now, this is really interesting. I keep looking, every time I present, I look at, are there any Hadoop breaches? Have there been any Hadoop breaches? I haven't found any yet. Has anybody? This is so interesting to me. Like, aren't the hackers figuring out with big data they should learn, Hadoop and how to get into a Hadoop system, and even the number of vulnerabilities. This will blow you away. So the vulnerability database says, there's something like 4 open Apache Hadoop vulnerabilities right now, 2 from 2012 and 2 from 2014. There's 4 more for Cloudera's version, I think 4 for Hortonworks, and then, you know, in admission we have 3. So there's something's going on that, like, I don't understand why there isn't more attention paid, and in doing more research, I think I'm getting some of the answers, but we'll get to that in just a moment. It's very immature. There's a lot less security governance discipline, and it's rapidly evolving. There's an article I put in there. It's titled, CIOs Still Don't Care About Hadoop Data Security. Ouch. Why? Because they're trying to figure out how to use it. And so when you look at this study, I think it was like 2% of them said that you know, what was preventing them from moving ahead with Hadoop was security. It's not. It's getting value, but as I said, as we go production, it's really going to start hitting. And that's probably why we haven't seen much in that area. But to give you an idea of how immature this area is, in February of this year, Cloudera reported one CVE vulnerability. They store the LDAP bind password in plain text in just, you know, open readable files under etc Hadoop, so local users can get at the password. Hello, I mean, that's pretty bad. So that's really what we're seeing, and I would suggest, you know, making buddies with those folks, or maybe bringing some of them in, bringing some data scientists on board. And the other thing I want to point out is a lot of security professionals are using Hadoop. Why? To do security analytics, you know, because it's a great place to run a lot of algorithms and see if you can find patterns. We also have this challenge with new types of data and new privacy implications, whether it's smart metering, health monitors, connected home, connected car. You know, the potential for privacy risks is really exponential, and legislation is not catching up with it, and which is why I'll talk about that in the next slide. And then there's new uses of data, and that is where it gets challenging, because when you change the use of data without changing your privacy notice, you're actually in privacy violation. And the FTC has come after a lot of companies for this, and it can cost a lot of money to get out of it. So that brings the question, is it cool or is it creepy? Right? I love that she's kind of got this listening device, and she must be hearing something really super interesting. I actually was looking for, Googling for an image cool or creepy, and I found this, and this webpage was written in Hungarian, and the only thing I could recognize was the name Glenn Greenwald. Does anyone know who Glenn Greenwald is? He broke the Snowden story, so I thought, okay, I have to put this image in here. So that when I bring this up, it's because the information we collect can enable us to get really cool services, or it can be super creepy. So, you know, the great example is a retailer, Target, and they're very good at being data scientists. So their analytics were so good that they figured out a teen was pregnant before her father did. And it was a combination of purchasing unscented lotions and large tote bags, which could be used as diaper bags. So they sent targeted ads to her on those products, and Dad called up, said, what are you doing? And they said, oh, well, you know, anyway, you get the point. It's not illegal. So I call this privacy ethics. It's really thinking about what's right and giving a consumer choice. Because some consumers, for example, you know, sending diaper samples to a woman with a newborn is probably okay for a lot of people. But, you know, it's probably not okay, like getting unsolicited ads based on your location. Or, you know, what about sending baby food offers to someone who just purchased a pregnancy test? Doesn't that make you a little bit queasy? It makes me queasy. So, you know, we need to think about that. So let's move on and talk about the big data life cycle and where I see it starting and where it's going. It's really been in this search and survey, exploratory and analytics until recently. And then when you stand it up as a production environment, it goes operational, guess what? That's when you get the call, hey, we're gonna hook up this new predictive analytics application and we need to talk about security. I mean, even now I'm working on several projects with our analytics group where they're putting together things and they're, you know, making sure that they want to incorporate security as well, because why? They've been trying to, you know, work on the analytics part first. So I think of this as fit for purpose security and privacy, where we start from this realm of initial use cases and then we move to using for business decisions. And typically in the beginning, realize that Hadoop was invented to be behind a big old firewall used by a handful of users in a highly secure environment. So security really wasn't put in there by design. And now that changes, so we do need to be thinking about it quite a bit more. The change management's also sporadic, no data retention requirements, no regulation, just get that data in there, and now it's interesting. Well, now we have to think about all these other aspects, whether it's encrypting, auditing, making sure you preserve data for a period of time. And that brings us to a couple of quick slides on privacy, because a lot of folks confuse what privacy and security are. And I think of privacy as the why and the what, and the security as the how. So privacy is basically figuring out, making sure your information that you get is accurate, it's safeguarded, you limit the access, you honor the choices of the owner, and also on how that data is shared and disposed of. And data security is the technical safeguards. So there is a lot of overlap, because of course you have to have security for privacy. You don't have to have privacy for security. And that brings us to the question of what is considered personal and PII, and it depends. And as you're developing and working in big data environments, this is absolutely critical to understand that anything that identifies an individual is considered personal information. Anything. And our challenge in the US is we have 47 states that have breach notification laws. 3 of them don't. And the initials are NSA. How about that? That's kind of strange, isn't it? But each one of those states has different regulations, and of course the EU has different regulations. And if you follow the news, you know that a couple of weeks ago the Safe Harbor data sharing agreement between the US and the EU was struck down. So, and a lot of it has to do with, things that happen, let's just say PRISM. And so you want to think about what is personal, and it's pretty much anything, and even cell phone location. There's a study 3 years ago, 15 months of human mobility data, and for 1.5 million individuals with hourly data points. Guess how many data points were needed to uniquely identify 95% of the individuals? How many points? What's the minimum number of data points? Anyone want to guess? 3, you're very close. It's 4. That doesn't scare you when you have your app tracking on. Like, pardon me, but if you have an app, there's no need to track someone's location if you're not using it unless you give permission. So that's my take on it. At any rate, I've said enough on that. So here's the big red caution. Make sure you talk to your legal and compliance, because it really is a legal compliance policy issue to decide what is and what isn't, and it's also about risk. All right, now we get to the technical part of the presentation, and we deep dive down very quickly. So what's the architecture for security and privacy for big data? Well, it really is going to depend. It depends on your implementation, your priorities, and your risk appetite. And when I talk to clients, I would advise them on what are the common controls and what I recommend. And they may not implement all of them. Now, this is a big old chart, and it basically says security, the same disciplines apply, but ... So in the stack, we start with the risk and compliance, governance, risk and compliance. That's pretty much the same. It's policies. Security and intelligence and analytics, yeah, pretty much the same. If you're using a SIM, the alerting, all about the same. Identity and access management, it's a mess. I have to tell you, it is highly, highly immature. Most Hadoop, at least I'm talking about Hadoop, the NoSQLs and the databases are quite a bit better. But most of them are relying on either a combination of Kerberos and OS. There are some open source projects like Apache Sentry and Apache Knox Gateway, and that can help with, and also role-based access control with Sentry and Ranger, 2 other open source projects. So, that does really help, but still, it's highly, highly incomplete and very immature, and I believe it'll be evolving more and more. Now, data security and privacy. This is actually more mature, and I'll tell you why, because data security and privacy until pretty recently was kind of in the data organization, and even in IBM, our data security products were in the analytics organization until January of this year. So there's this recognition that data security has to be part of the rest of security. Why? Well, a lot of security came out of network admins, sysadmins, and then app developers who were interested in hacking, and not so much the DBA crowd. So that's changed quite a bit. We still see a patchwork of vendors who are doing their own stuff, and that makes it hard when you manage an infrastructure. So, like Cloudera acquired Gazang for encryption, Hortonworks bought XA Source. Now we get to AppSec. I have been scratching my head over this one. I talked to my colleagues, and these are guys who are like, worldwide AppSec leads, so they travel over the world, talk to a lot of folks, and I said, how much Hadoop are you seeing? Like, what are you seeing? And they're like, well, we're not really seeing much. And I'm like, how is that possible? Well, I think there's two reasons. One is that a lot of folks are just buying purpose-built apps. They're not productionizing stuff yet. They're not doing the integration. That's one reason. I think the other is that a lot of what you're seeing is just calling REST APIs. And it's just a REST API and there's some JSON, and it doesn't really look that different. So a lot of what we're seeing doesn't look that different from your side of the fence. But I still kind of wonder, why is it that we're not seeing a lot of work being done in AppSec for Hadoop specifically? And if you'd like to talk to me afterwards, I'd love your insight into that. Also, we do see more of this authentication with PAM and LDAP. I forgot to mention that. And then infrastructure protection, it's the network. So network is network, and I think it's pretty much the same. Advanced fraud protection, we use that quite a bit with Hadoop. Now we talk about the Hadoop security architecture, and you'll see some of the common elements that are in the standard world of things, the structured world, whether that's the network security, audit logging, alerting, encryption, authentication, admin and configuration, certificate management, pretty much the same. But as I said, the challenge is bringing that together with what you already have in the enterprise, and it really isn't that easy. I believe it'll be getting better, but still, there's challenges. And recognize you're dealing with both static data at rest, so maybe masking in addition to encryption, and then you've got dynamic data. You've got data flowing. And I feel pretty strongly that in the world of security, we've done a terrible job of security on data flows and understanding data flows, and especially as they relate to managing privacy controls. So, and more of the challenge is that as Hadoop has matured, the avenues to get into the cluster have changed. It used to be that you'd have to go through the central, the node, the name node to get the stuff. And now not so much. You pretty much go everywhere else because it's the interest of performance. So what does it mean? It means you've got to put agents on every one of those nodes to monitor. So there's a little bit more work involved. So what are the privacy and security core disciplines that we have been observing, and what are clients doing, and where are the more mature products, and what can you actually do? First is you got to know where your sensitive data is and who has access. That's still not really easy to do because the way that JSON is structured, you have to look for the data and then the data elements and understand what they are. And I can tell you that at IBM we're still working on a lot of that. We do have methods to do it that take a little bit more work, and it has to do with using text analytics. So we use our own text analytics to go crawl and look for stuff. Then you need to classify the assets and quantify the risk. You got to quantify the risk against the value, decide about the vulnerabilities, and then decide how you're going to protect it. And I talked about the identity and access management. The big one is activity monitoring, and that has developed very well over the last couple of years. We've done a lot of work with clients from credit card companies to even to pet retailers, surprisingly enough. They want to make sure that customer data doesn't come out. Encryption, I think we all know about encryption, pros and cons. I'm not going to talk about that. I do see more redaction and masking going on, so hiding and obscuring data. Locking down the environments, even segmenting the network. I also think that a lot of the reason that Hadoop hasn't been breached as much is probably those networks are segmented and they're kind of off to the side. And so that reduces the risk. But again, as we go to production, we really got to be thinking about that. And then the last is the monitoring and auditing, whether it's defining your metrics and auditing and reporting for compliance, et cetera. I believe that real-time data activity monitoring in the world of Hadoop is absolutely critical, and that's this concept of capturing the network traffic, teeing off the network traffic with an agent, not with a spam port, and monitoring the reads, the writes, who's doing what, and then being able to alert, report on, or even block on that bad traffic. And I'll leave you to read some of the text, but that approach has been working very, very well. Again, our bigger challenge was as we adopted the newer architectures, having to install the monitoring agents on every node. And now we're able to automate that, which is a good thing. So here's an example. This is from one of our tools called Guardian. And what it does is it basically captures all this traffic into a hardened repository on an appliance, and then you can run reports, and you can look for certain users, you can look for certain activity, and you can also use machine learning to figure out what are those unusual patterns. And then, I apologize, the black's a little hard to read, but basically when a privileged user tries to read customer data and that's detected via policy, we're able to block. So we can put policies in place that look for specific IP addresses that are, not whitelisted, look for specific access to data elements. You see a SQL select there. That's because a lot of Hadoop has SQL interfaces now. So blocking, I think monitoring and blocking is a good way to go. And then last but not least, I'll talk about data obfuscation and the massive confusion about what it is. There's a lot of ways to do it. One is masking, where you substitute the value for something fictitious that looks real. That came out of the world of test data management, and in test databases, you really shouldn't have credit cards. And you can do that very well in Hadoop, whether dynamically or statically. You can also redact, so put little X's or asterisks, etc. Tokenization, something that gets used. Pros and cons, pros easy, cons performance, and of course our friend encryption. So here's an example. I can take an SSN, and I have tables here. It's basically the same with Hadoop, being able to apply a bunch of algorithms to very quickly mask that data. Here's another one. This is an example of using redaction with Impala and Hive, and I can basically capture that network data stream, look for string regex expressions, and you could use pre-built ones, and then redact that so that a non-authorized user will not be able to see that, and you can do that on a role and policy type basis. Then when you put it all together, it becomes a lot of fun, and that is you might want to front end it with an information catalog so business users know what the information is, classify that data, and then decide how you're going to process it. Normally, my best recommendation is if you can pre-process it on the way in and apply your rules on the way in, whether it's masking or cleansing. That's a good thing. And anonymizing, there's a lot of data you can anonymize, like that location data. You really don't need to know that it's me who's using my Fitbit or what other device. And then, of course, is that real-time alerting and the activity monitoring over at the top. Some final words of advice is know your data and understand the data and the trust factor, and decide how you're going to operationalize it. Do a privacy impact and a security risk assessment, and then decide what controls you're going to use. It's really not a one-size-fits all. You're wasting your time if you're locking down data that is not useless to anybody. So that's some good things. And then there's also some recommended approaches for monitoring. And finally, keys to success is managing that security and privacy at your point of impact. And understanding that you need to have a holistic approach to safeguard information no matter what. And that I do believe that Hadoop is very viable if you think about the controls you need, you do your homework, and then you look for solutions that are going to integrate with what you have in the rest of your enterprise. But more than anything, make sure that you talk to your friends who are doing this work, because you really don't want to be surprised at the last minute, and you definitely don't want to be surprised when a breach happens because nobody was paying any attention to the security in that environment. So with that, I finished in record time. I normally go over. We have time for questions, and I thank you.
10 minutes for questions. So I'll bring the microphone over to you if you have a question for the recording.
Hi, thanks for your talk, loved it. You mentioned that there were some difficulties with doing analytics on JSON and presumably other kinds of structured data, and that you were currently solving that by doing just sort of like free-form text analytics style stuff. I was wondering if you could elaborate on like why is JSON tricky?
No, not JSON tricky per se. I think it's for classification for sensitive data discovery, it's tricky. That was my point, because you have to use text analytics to look for the the names of the elements and then the values, and see how they're tied together. And that's a little bit harder than just just doing a regex expression and finding a string. Like, what's the context around that? That's really where the challenge is. Analytics are, JSON is the de facto data interchange format. I mean, that's what everyone is using, and I think we've done a pretty good job of that. Our tools over the last 3 years have matured hugely, like leaps and bounds, and it's a lot easier to even do a lot of these things now than before. So sorry, I needed to clarify that. Good question.
When you have mixed data sets and you're loading them into the platform, when there's multiple classification levels, let's say sensitive data and non-sensitive data, have you seen methods where you're tagging that data on the way in work, or are you seeing more isolation where you're actually pushing the data into separate infrastructure zones where you're classifying sensitive data away from maybe less sensitive data, so you can actually kind of detect where you might need to put additional controls?
That's such a great question. So to rephrase it, have you seen which of the two approaches have you seen where or that you tag the data that it comes in up front, or you put it in different places? I would say more putting it in different places right now, because the tagging is still maturing, and there's some interesting things going on in that area. And I believe my perspective is we should be tagging all data automatically, and then we wouldn't have these issues, because we would know, as data flows, we go, whoop, that's red data, be careful, watch that one, right? I mean, if we had done that from the very beginning, we wouldn't be in this mess right now where we have to spend, I have clients literally who think it's a good idea to classify all their data and take 5 years to do it before they even do anything to protect it. One of them is a major automaker, and believe me, it drives me nuts. So it's a very good question. I'd say watch this space. It is still maturing. It's definitely something that I'm doing a bit of work on with our analytics team right now. So, yeah.
We still have some time for questions, about 7 minutes. Anybody else?
Or even feedback. I'd love to hear what you're all seeing and what you're doing, and what are the trends that you're observing?
I can add one more. Do you run into Elasticsearch at all? It's becoming kind of hot in the security space.
Somewhat, not much. It's come up a couple times, but no, not really.
All right. Well, thank you, Cindy.
Great. Thank you, everyone.
Appreciate you coming.